Folks. We appreciate you joining us. We appreciate you joining us ahead of the hour. We're going to give it just a minute or two and we'll get started right at 1 o'clock. Thank you.
Sounds good. Video. Okay, yeah, you need to stop your video. Stop it. Oh, wait, hit stop.
Hello, folks. Thank you for joining us. We're going to give it just a minute here as folks come in and give them a moment to get settled, and we will get underway. Thank you.
Before we get going, I see we've got a new participant with initials SW. If you wouldn't mind, please putting into the chat your full name and email address. Perhaps your organization would be helpful as well. Whoever is SW in the meeting, we'd love to know who you are. Thank you.
Okay, we'll go ahead and get started right at 1 o'clock. I know there are folks are still rolling in, so please take a minute to get yourself settled here. Welcome to an office hour for Public Service Company of New Mexico's 2026 Integrated Resource Plan. My name is Kathy Boyce. I'm a GridWorks facilitator. I'm joined here today by Margie Tatro and Deborah Shields. We are here to discuss PNM's plans for transmissioning modeling. This is a segment that we didn't get to at last week's workshop number 3, so we are going to do a little bit of catch up today and spend some time on that. Deb, if I could ask you to advance to the next slide, please. So our objectives here today is to present that transmission modeling inputs and assumptions that we didn't get to in workshop 3, and then give you all some time for questions and answers. And more globally, the goal here is to help prepare you all to understand the base case model results that we anticipate for workshop number 4. So our agenda, we have an hour together today. I'm going to hand it over to the PNM team shortly to go through the transmission modeling slides. We'll open it up then for Q&A and then adjourn by 2 o'clock. So just to level set, next slide, if you would, please. To refresh a little bit on our workshop norms, we do ask that you hold your questions during the presentation. Give the presenter a chance to work through the full material, and you might find that your question is touched upon during that presentation. And then we would ask that we start with prioritizing verbal questions, and so that you can ask the question yourself, hear the answer, and give some time for that shared dialogue. I also want to recognize that this is a process for stakeholder input. We are not in a litigated proceeding here. We are working to be constructive towards shared understanding, and we're not here to cross-examine each other. So please be respectful in your comments. Recognize that we are all working with good intentions and give each other the benefit of the doubt. Share your ideas and leave time for others, and be mindful of participants that are behind you. We have had quite a flood of questions, and so just recognize that other folks are waiting for their turn. So the purpose today, again, is to focus specifically on the transmission modeling. We recognize there were a fair number of questions from workshop 3 on other topic areas. We are working to schedule another office hour to address those questions, so we will come back to those. So today's purpose is really just for transmission. And with that, I think we are ready to hand it over to PNM.
All right. waiting to get the slideshow up here. Anyway, I'd like to welcome everyone to the transmission office hours following workshop 3. We had planned to touch on this subject in workshop 3, but basically decided to move it to an office hours due to time. PNM has been working on means to move the IRP towards a more integrated system plan from an IRP for a while now. We have provided some previous information in IRPs to talk about some of the reasons for that. And I'll go through a little bit of that today, but we'll probably point you primarily to some of the previous IRP material to look at what was posted there and some of the challenges on the New Mexico transmission network. A lot of it ties to third-party utilization of our system and how that affects what's actually flowing on the system and how we're modeling things in the zonal model versus the nodal model. So historically in the modeling, in the zonal model, locational treatment of resources has always been thought about, but it's typically handled by looking at resources, looking at where they would most likely be located, and in some cases, resources can be in multiple locations. And then with that, in going through the capacity expansion, there would be a cost adder depending upon location that was utilized in those models. Usually you put in a cost adder because you assume transmission was required in certain locations, but there doesn't give a very good idea of what kind of congestion and curtailment might actually occur for those locations. So the zonal model may not really provide the insight on the transmission that's being looked for. Resources with least cost locational ladders, assuming everything else is the same, would always be selected in the zonal model. And the zonal model, it was not possible to capture third-party transmission usage, which for PNM represents over 50% of the total utilization of the system. We will continue to develop candidate portfolios in the zonal model, but study transmission impacts also in the nodal analysis to capture potential conflicts and total flows on the transmission system due to other uses. Identification of transmission curtailment is a
Each person driving isn't really count.
Sorry, I'm going to interrupt for just a minute. We're getting a little background noise. Can I just ask everybody to make sure they've muted their cameras, please? Their microphones, please.
So I'm trying to help go through with the, in this IRP, previous IRPs, we did zonal capacity expansion with the zonal transmission or zonal network model. This one will still be doing zonal capacity expansion with the zonal network model, but adding the nodal transmission analysis to that. So why nodal has been covered in the previous IRPs. I might point out a lot of it has to do with the fact that we have a significant amount of point-to-point transmission utilization. A lot of this is for transferring wind generation across the system. Some of it's for serving other VAs within New Mexico. And then some of it's basically legacy service within PNM system that's been there for a while, hasn't really become defined as point-to-point. And then we also have a large number of network transmission customers that basically serve their load off of PNM's transmission system. That service represents over 50% of what we see on the system in terms of actual flows and utilization. In the zonal model, we don't model any of that customer, any of those transmission customers. The only modeling is done of flows on transmission is for PNM owned resources serving PNM load. By going to a nodal model, it provides a means to assess resources and portfolio additions while accounting for the wholesale system uses. That allows us to get a better handle on curtailment. It'll allow us to try to quantify path congestion or congested paths congestion costs, and also provides an opportunity to look at whether there's really significant loss differences between different scenarios. So the next part of this is really trying to talk about what steps will we go through to try to incorporate nodal modeling into the IRP analysis. So as said before, we will be continuing to develop capacity expansion candidate portfolios through the zonal model for a particular future and sensitivity. And the future and sensitivities have been reviewed in a couple of our workshops now. People have a question on what those are. What we get out of the zonal capacity expansion model is going to be a candidate portfolio, and I'll go into an example of what that looks like. Many of you already know, but I'll go touch on that just to make sure it's clear. As noted in workshop 3, there's other information that comes out of there. One of the more key points is the net present value of our portfolio, of that particular candidate portfolio for a particular future and sensitivity. And then there's a lot of information that can be extracted from that. Emissions is one of the big ones that gets looked at. The candidate portfolio details include technology types and amounts by year, but candidate resources are not location specific. I seem to be,
There we go.
oh,
You got it moved.
okay. All right, so here's an example of what we see in a typical candidate portfolio. Generally, what comes out of the zonal model is going to be a bit more extensive than this. It'll have more resources added over the same time period. Here it's basically showing that we've got 500 megawatts of solar were picked in this candidate portfolio, but at 2 different time frames. First time frame for resources was 2033 for 200 megawatts of solar. In that same time frame, the candidate portfolio included 8-hour battery storage, in this case 100 megawatts, also 2033 time frame. The next resource was selected as 400 megawatts of wind, and that was a couple years later. Then this one shows long duration storage of 200 megawatts being picked in 2038, and going out further in time to 2040, 300 megawatts of solar being selected. To the extent that transmission cost adders were actually used in the zonal model, that can affect the outcome of these candidate portfolios. PNM is going to propose that many of the resources will be looked at initially without putting in transmission cost adders, so we can try to better define those through the nodal model. Location of the resources is important to understanding the transmission implications. The nodal model provides significantly more detail on that. And one of the key things is there are multiple resource location options for certain technologies, particularly things like solar generation. Solar and battery generally can be pretty flexible on where they can be located. So once you have a candidate portfolio, what do we have to do with that? So in the nodal model, we're basically going to have to get that added to the nodal database in some fashion. The nodal requires that very specific locations be selected. This usually requires a fair amount of experience with the transmission grid, and a fair amount of judgment play a role in picking those locations. Once those locations are picked, you go through the effort of mapping or modifying the database to tie in those candidate resources at specific locations, and then you perform the nodal analysis run. And I'll get to some of what is the output you get from that nodal analysis run in a short period. So here's an example of that candidate portfolio, kind of where we've gone in and we've selected locations to put that candidate portfolio on the transmission grid. The nodal model contains a full connection model of transmission to systems with loads and resources. And the state of the resources have to be located at a particular grid. So you're effectively putting them in a very exact geographical location on where they tie in. Historical location for technology will guide initial mapping, and I'll go into that a little bit more. And model runs determine flows on all lines and transformers using a power flow solution. If flow exceeds path limits, which can be defined as basically interfaces of multiple lines, or exceed individual line or transformer limits, the model redispatches the resource to relieve those limits. The redispatch comes at a cost that requires that resources be dispatched out of economic order. In the case of New Mexico, historically, for PNM system, the vast majority of our load is in the Rio Grande Valley area, in the center of the map here. A lot of our resources were historically located up in the Four Corners area or entered the state up there. And we have an area in the state that brings a lot of power through our system to Four Corners and out of state, where there's a lot of wind generation over in eastern New Mexico. So going into this, on this next map, I kind of show what in the zonal model becomes our network model, kind of showing the transfers to those different areas. You can see we've got that Four Corners, Palo Verde, San Juan area, the PNM load area, PNM North, the high wind area historically, and then one I didn't point out, but we have load down in southern New Mexico as well. The loads and resources are modeled in zones, and there are estimates of transfer capability to other zones. Only PNM load and resources are captured, requiring that zone transfer limits are estimated amount of transfer PNM can utilize between these regions. In reality, the capacity of between the regions is probably quite a bit greater, but we reduce it to try to capture what PNM would have access to. And the other remaining capacity is utilized by the other transmission customers. So actual flows and limits on the system are a function of all uses of the system and the laws of physics. So this diagram here is just trying to sort of demonstrate what the different zones in the zonal model, what geographical area they tend to represent. And so we had the Four Corners area, the PNM load area, which does contain significant resources within it as well as load. And then the eastern area where mostly transfers are driven by wind generation today. And then we have a zone down in the south, which represents the two areas of load that PNM serves down there. That's treated as a single area in the zonal model. Connections to entities outside the state have typically been shown as connecting to that Four Corners, Palo Verde, and San Juan zone within PNM's area. Anyway, when we come up with how we map our transmission, map the candidate portfolio, these zones will continue to guide how some of the mapping is selected. And that's because these were created because they represent a lot of the major zones with transmission limitations between them. So looking at what we might do today, if I took that candidate portfolio we had, with the solar, battery storage, long duration storage, and wind, In the nodal model, we would pick very specific stations to tie those into. In this case, the map I showed, I'm selecting the Four Corners 345 kV bus, which is effectively in that Four Corners Palo Verde San Juan zone. There are other options, but for the purpose of the IRP, we will pick candidate buses to connect these resources to. For the wind, we put that out in our eastern area, connecting to the Western Spirit 345 kV station. That area is located in what's not is in the zonal model, the PNM Eastern Zone. And the long duration storage and the solar coming in later is basically assumed to be built in the Albuquerque area. And again, we have numerous options in the area for selection of where to connect those. But for the purpose of the IRP, we will select a very limited candidate switching station buses to tie those into. So once we do that, we've mapped it and we make our run, you run the nodal model effectively. The orange block here is showing what kind of information we can get out of that, which will include losses, resource curtailment, helps identify congested paths and also congestion caused on the congestion cost associated with the paths. From there, we basically would take that information and would have to process it. What do we do with that? Try to understand whether transmission enhancements are actually warranted. So here I've set up an example of results that we would get out of that. So here, that first row is showing that we have a path between Four Corners and Albuquerque. And that path today flows in both directions to its full limits, particularly exporting out of the state. The model has come up with congestion on that path that adds up to about $7 million annually. This isn't necessarily tied directly to this isn't tied to the candidate portfolio. This is based on some initial runs we have made. In eastern New Mexico, the path that brings wind to the Albuquerque area is showing congestion of about $1 million a year. Those correspond to about 218 hours of congestion between Four Corners and Albuquerque Four Corners, and about 30 hours of congestion out of eastern New Mexico. The effect of those is to create curtailments of resources. In this case, the model was showing curtailments for entirely wind and solar resources that were there. The percentage is relatively small. And then it also quantifies for the New Mexico transmission system the losses that we would incur. So the next column provides an example of the first one. I've run through the nodal model. I've obtained these results. The next one I would say, well, what if I wanted to address that congestion between Four Corners and Albuquerque? Came up with the transmission expansion option, which we would then put into the nodal model and rerun that model. In this case, the transmission expansion was plenty adequate to address all congestion. So you're seeing that there is no congestion cost and no congestion hours in that second column. The expansion did nothing to increase capacity out of eastern New Mexico, so those results are not changed. But the effect on the curtailments that were occurring was to reduce those. There still could be reasons you'd see some curtailment, but the nodal model would tell us how effectively it addressed those curtailments. And then typically in this case, we were assuming a fairly large 345 transmission addition. You're typically going to see a fairly big benefits transmission losses from large capacity additions on the system. But the trade-off there is you're putting in a transmission project that's in the hundreds of millions of dollars, and you're going to have an annual carrying cost that's quite steep. In this case, it's probably doesn't justify putting the transmission in just to avoid the congestion cost and curtailment. I'm waiting for the slide to change. I don't know if that's a network issue or what. Come on, there we go. So anyway, that's kind of the process we'll go through to get results from the nodal model and try to factor those in. From that information, coming up with the candidate transmission additions, I'll touch on in just a minute. But one of the things, again, on resource location, is certain technologies that are fairly flexible and can go in a lot of places. With solar, PNM has put solar in the Albuquerque area up at San Juan Four Corners, and a fair amount down south of Albuquerque in the Belen and Las Lunas area. Today, we don't have solar in eastern New Mexico, but it would certainly be a possibility. It could even be located there. Wind generation is much more restricted, at least the most effective wind generation in the state, largely to eastern New Mexico. And then you have some potentials up in the northeastern part of the state with very limited transmission connection today, virtually no connection to the western grid. Geothermal, one of the resources we'll be studying. We are working on and seeking input on potential locations that would make sense to include in the IRP evaluation so that the transmission can be factored in. The size of the geothermal, whether it's looking at a small 10 megawatt project or a much larger one, will certainly make a difference on how many locations you can place those. But PNM's transmission facilities today are really not situated near some of the better advanced geothermal sites. Pump storage, PNM will probably be planning to assume the San Juan Four Corners area for that location, in large part because that's where the only projects that we have seen interest in have been shown. And then things like compressed air energy storage, we probably would like some input there as well, but we assume the southeast New Mexico area is one of the higher potentials, but that again is fairly isolated from PNM's transmission system and would be expected to have a high transmission cost. So in developing transmission additions, this is just a high level summary slide and there'll be more to come on that, but we would expect to use information be guided by the 20-year transmission plan projects, which was a study PNM completed last year. It was an ongoing effort over a 2 to 3 year period. It is a study posted on PNM's website. It will be used to provide information on the cost and schedule of potential alternatives, to provide the capacity benefit that you could expect from those alternatives. And it looks strictly at 345 kV projects. Since there are other possible locations, depending upon the size of a resource, we would also use more recent interconnection studies or 440 filings to get per unit cost for 115 kV and below. We would probably restrict the IRP to primarily looking at 115 and 345 interconnection. And with that information, we will continue to work on identifying specific projects and costs that will be used in the IRP and make that information available. Once you've selected those candidate resources, you're rerunning the nodal model with the transmission modifications as shown above. Once you put those in, how they affect these different benefits for congestion and curtailment. With that, it confirms whether the projects are actually effective in accomplishing what you want. Once that's done, we would go back take that transmission cost that was developed from the nodal model run and rerun the capacity expansion in zonal with the transmission cost included. That creates the possibility that the candidate portfolio that you were looking at for particular future sensitivity could change. So there may be some iterations that end up involved there. And then resource locations, going back to the previous slide a bit, that are clearly not connected near the transmission system. We're proposing that you would still have some cost adders in the zone for those. Switching subjects a little bit, PNM had proposed to look at some transmission sensitivities in this IRP process, independent of necessarily any particular candidate portfolio, to try to identify what the potential benefits of better connections to markets for New Mexico would look like, along with the potential benefits to PNM. The 4 projects that were selected were Rio Sol transmission line. This is a line being built to really move power from eastern New Mexico to Arizona, get a lot of that wind out of there. We would look at a potential interconnection to that project, which gives us better access in theory then to markets in Arizona and the California ISO. The Sunzia wind collector system is been built. It's being commissioned and completed. The wind for that is coming on again. That connects eastern New Mexico to Arizona and to California, and the facility itself actually resides in the California ISO balancing authority area. So we're looking at an interconnection to that fairly complex tie because of the size of the system. But that one will provide a direct connection to the California ISO within New Mexico. We're looking at what would potentially happen if we had a better interconnection of approximately 1,000 megawatts with the Southwest Power Pool. Does that provide market benefits to PNM and New Mexico as a whole? And then we're looking at what could the benefit be of additional transmission capacity between Albuquerque and Four Corners. So the first project, the Rio Sol sensitivity, is really a fairly short transmission line, although it's not cheap because of the need to manage flow on it. It would be connecting, stepping down from 500, connecting to a 345 line up to PNM's Hidden Mountain area. The mileage is fairly short, but that would provide the benefit to see what a tie to a stronger tie to the west and an alternative tie to the west would provide. Sunzia is similar. It's a fairly short tie to connect the Sunzia system to PNM's Western Spirit switching station. Again, because of there's some technical challenges with that keep the project cost fairly high for the distance of the line. I believe that distance is only around 5 miles. And the Blackwater DC tie sensitivity basically requires a much larger converter station than in the Clovis area than PNM owns today. And the station in Clovis today is out of service and expected to stay that way. To get the power transferred close to the PNM system would also require transmission. So that whole project comes in at a cost of around $1.5 billion and would probably have a long lead time on it. And then we're looking at additional capacity between Four Corners and Albuquerque to get to the Four Corners area markets and Arizona markets, and with participants who can interconnect up there. And this was just an example of candidate projects that we would use that are in the 20-year transmission outlook. Kind of gives a feel for what we see as schedule and cost of these different projects. I believe the mileage is in that study, although I didn't include it here. And there's a link down below on the slide that will take you to that transmission study. And so that's pretty much what I've got for today.
Thank you, Tom. We appreciate the additional time to work through. We'll go ahead and take some questions here, and I'm going to ask folks to raise your hands. While you're composing your thoughts, I'm going to actually pull up a couple questions that we had during workshop number 3, and these are mostly clarifications. So Tom, maybe if you could go back to slide 15, please. So of those 4 transmission line possibilities, one question from last week, is PNM attempting to select between these lines, or can 2 or more lines be selected in the future, the current trends and policy future that PNM has mapped out?
So the current trends and policy future is really a load forecast future. It doesn't specifically have a transmission information that goes with it. In terms of going through this IRP process, we were going to explore the different connections and the potential costs and benefits of them. There's nothing that we've specifically said you couldn't look at combining them. That might make sense, especially if you were tying to SPP and wanting to get the 4 corners. Some of that might be useful, or if you were wanting to tie to SPP and utilize SunZ or Rio Sol. But we certainly haven't counted that out.
Okay, so these decisions are not mutually exclusive. There may be 1 or 2 from each of these to be considered.
Yeah.
Similarly, and I think this is just a clarification, the SunZia and Rio Sol, those are big transmission lines that have been in the news for folks who are following the industry. I think the question is PNM proposing to participate in the SunZia and Rio Sol projects, or are these specifically the tie lines to get to those big transmission lines?
So I can answer that one, Tom.
Okay.
So not proposing to be owners of these, just looking at, would it be beneficial for PNM customers to have a connection to it? So it's effectively having another market connection for PNM's retail footprint. So just trying to see what kind of benefit that provides to customers when compared to other alternatives or not.
Thank you. And that was Lori Williams from PNM.
Oh yeah, sorry. And I'm having computer problems, so I am trying to figure out what's going on, and I've been on my phone thus far, so apologies
Thank
for
you.
that.
Thank you. We appreciate you muscling through to join us. Great. Okay, thank you. A couple more questions, and then I am going to go to hands that are in the chat. On the very last slide, Tom, before questions, that sample project portfolio. So folks are looking for mileage for those projects. Where could they go to find the mileage for each of those?
Lori, maybe you know whether that's actually in the 20-year outlook. I don't remember, but I thought it was.
Yeah, I don't remember either, but I can check, and we'll make sure to pop a note back into the chat during this call. I'll go look it up and see if we put the mileages in there in a particular table and let you know if that's there.
Thank you. And I might also ask somebody from PNM to drop in that link, the transmission outlook, into the chat for folks so they can access it themselves.
Why do you do that? I can't get to it.
Thank you. And one more question that's a holdover from last week. Can industrial project developers access the nodal model outputs, that detail from the nodal analysis? Is it possible to map transmission line options along Paseo del Volcan, both on the Bernalillo and Sandoval County sides?
It certainly is possible to map them. We would probably only consider that if there's scenarios we're looking at that seem to drive the need for transmission in that area.
Okay, so if there's a county economic developer that is interested in that, is there maybe an account manager that they could work with at PNM to kind of kick around some ideas?
Hopefully they've already know who the account manager would be they could work with, but certainly if they don't, they might want to send that question to IRP@pnm.com.
Okay.
We do,
Okay.
Kathy, we have a department that for economic development projects, we have an entire department dedicated to working with counties, economic development customers, those kinds of things when potential economic development projects come through that folks are wanting to understand what would be involved or required. So that's going on all the time, not necessarily rising to an IRP level, but it is something that is, I can tell you, continuously takes place between PNM and any interested parties.
Good, thank you. Okay, and we will make that connection for the folks that were inquiring. Thank you. Okay, so I'm going to head to the chat or to the hands raised. Thank you for your patience. I see quite a few, so just please be brief in your comments so we can get to everybody. Jacob Richardson from WRA will take you first, and then Glenn Wickel, you're up next.
Thank you, Tom, for that helpful presentation. Just a quick question about how Encompass is treating the wheel-throughs. You mentioned that over 50% of the transmission utilization is not related to PNM's native load. So is there an iterative process where, for example, if the portfolio selects, or if the model selects a transmission line and more than half of that capacity is being used for wheel-throughs, is there a credit that then is added back to the capacity expansion to make that transmission project a little cheaper because there are benefits outside of just serving PNM's load? If you can maybe help explain how transmission is treated that way in the model.
So certainly I think the reason that we are trying to get to nodal is because in the zonal model, it is very difficult to actually capture that kind of wheel-through transaction and how it affects the transmission system. So if you're looking at this particular diagram here, we have 1,900 megawatts of wind connected to our transmission system that go out of state there. So when we have high wind conditions, you have a lot of counterflow from our perspective that goes from the Albuquerque to the Four Corners area. And one of the challenges we have is how do I capture that wind actually can take the system almost to a complete limit in that direction. How do we capture what's going on with PNM resources, especially during the middle of the day when solar is usually well above our load, especially in off-peak months. So you combine those two. When we have excess solar, a lot of it gets moved to the market and sold there. But when we have high wind, there's not capacity to move all that solar. So it plays a big role in how much curtailment would we expect to see tied to transmission within New Mexico. There are other reasons you could see curtailment, including just oversupply in the Western grid that leads to pricing, that negative pricing of the market. But this helps us to put in the nodal model. We model all of that wind generation and all of the third-party uses of the transmission system. And so that is part of what is flowing when we look at things in the nodal. None of those resources or third-party uses are considered in the zonal model.
Gotcha. Okay, so I guess maybe I misunderstood, but are the benefits associated with those less curtailments or wheel-throughs, are they incorporated back in as like a reducing that cost adder in a sense, or am I misunderstanding something? I apologize.
No, we're using them primarily to identify whether the transmission capacity for all uses is adequate. And if it's not, then you would go put a cost adder back into the zonal and rerun that.
Okay, thank you.
Thank you, Jacob. Glenn, and then we'll go to Barbara next.
So I have a two-part question that has to do with the new market transmission, I guess you would call it, both to the east and to the west. So to the east, we know we have this constrained and potentially non-functional Blackwater tie, and one of your diagrams shows a NMWEC connection from your eastern zone, but your sensitivity seems to show connecting from the Albuquerque area directly to SPP. So I just want to confirm that those are two different scenarios? And then I'm also wondering, are you going to hop around the existing broken or overloaded Blackwater tie?
Yeah, on your latter question, that Blackwater tie would have to be completely replaced. And I think you're referring, so it would be a totally new tie. The thought for the sensitivity here is that it will be a much bigger tie than existed in the past. So it would be replaced. I assume you're referring to this slide that has New Mexico wind on there.
What that means? I thought that meant western to eastern interconnection.
No, it's just a tie with a single wind farm that has a transmission limitation connecting to our system, basically.
Okay,
So
yeah,
that's
I
all
saw
that's
the dim blue ones as being market connections because that's what they were on the left. So I misunderstood your diagram.
correct.
Glenn, did
So
you have a second question?
Well, I just wanted to say about the Blackwater tie, we already saw from the EPE IRP that they also show that it's economically advantageous to rebuild the tie. So it looks like we might be looking at a new tie and a rebuilt tie, but I'll let you utilities figure that out. Going to the west, that provides, as you say, a direct connection to CAISO, which seems to be coinciding with joining the day-ahead market at CAISO. It seems like it's a complicated model to do the day-ahead market modeling along with the transmission. So how's that going to work in terms of figuring out the economics of building a new tie to CAISO?
So effectively, the nodal model will calculate price differences between areas. For CAISO, we will largely be using a price curve to set those at Palo Verde. And then we will see if the tie to CAISO in New Mexico actually receives the market benefit of that. Typically, prices end up being higher in New Mexico because of our distance from that market.
But
So it
yeah, it
sounds
really
like
is. Yeah, I think, Glenn,
Go
it
ahead.
really is to test whether market access can provide enough benefits for us that it makes sense for our customers to get some cost savings, whether it's in production cost. We don't have to start something or utilize something that's going to cost money. We can get something from the market. Vice versa, if we're over generating with our renewables, we have additional access to sell those rather than curtail. So all of those production cost benefits get calculated as a part of our analysis.
Right. So what I heard is you're going to use a simple price curve model to represent the CAISO EDEM market power.
That's right. And we'll have a market price for any of those connections that we make to the market. So not just the California ISO, but there'll be a price for connecting to the SPP, a set of market forwards, same thing at Four Corners. Very similar to what we've done in the past, but we've only really had the connection to Four Corners market and Palo Verde. This would be some additional markets and market forwards that we could dispatch against.
Thank
Oh,
you.
you mean the
I
Palo
just-
Verde hub? Okay, thank you. I thought you meant the power plant.
Okay.
No.
Thank you. Just recognizing we have a very full wait list here, so I'm going to keep us moving. Do want to recognize Stephen Jenkins dropped in a link there for us. Thank you, and the 20-year transmission plan, so please access that. And Lori, thank you. Double timing here. Notes that the links in the PNM's 20-year transmission outlook are not provided, but will be included on a site that we will offer a link to. So those answers are coming for you. All right, Barbara, we're going to turn to you, and then Evan, you're up next.
Okay, I have two questions. The first is kind of simple. On slide 12, there's a reference to something that maybe I didn't understand quite about congestive hours. And I was wondering what kind of units those are. I mean, they're more than the hours in a day.
Yeah, they're the hours in a total year that you're seeing congestion on a particular path.
Okay, so those are Those are your hours. Okay. And my other question actually has to do with a situation we have here in Santa Fe where we had a proposal. I don't know where it stands right now. Build out a rather large solar and BESS unit south of town that would connect to PNM. And I'm wondering how that kind of a build out or operation would impact on the transmission capacities of PNM and what kind of additional transmission you might be able to accept or what you would think of building out in a model to look at that kind of opportunity or whatever it is. That's the AES.
Okay.
I can try
Yeah.
that, Tom. So Barbara, really good question. So what PNM has going on, similar to economic development, we run federal transmission interconnection queues. So any generator that wants to interconnect to the grid in the United States has to follow a federal interconnection study process. So we as a company required to follow FERC just like every other utility that I'm personally aware of that's in our region is going through, and those generators are getting studies on can they connect to the transmission system, and if so, what kinds of network upgrades would be required to incorporate their output onto the system. So individual generators for very specific kinds of interconnections are not necessarily in the IRP. That's taking place in our transmission large generator interconnection FERC process continuously. It's been going on for the last 30 years. That's going on as we speak right now. So those kinds of things are getting defined in those studies and published. And then all of that, we understand what's in those queues, and that when we come to the broader IRP type studies, we're guided by what we know is going on in those queues.
Thank you, Lori.
Okay, so if I could expand on that, then
Sure.
Is there any of that in the IRP modeling now?
So it's a little different. When you get to the IRP, you don't want to be limited by what is in your large generator interconnection queue specifically, right? Because we may not have, like today, we don't have a single pumped hydro plant in our interconnection queue. We don't have a single geothermal plant in our interconnection queue. If we exclusively limited ourselves to the generation queue, we'd be leaving off a number of possibilities that we expect to see over the next 20 years. The queues are much more specific and near term, I would call it. I hope I'm explaining this well enough. But when we get to the IRP, it's kind of like, what are the technology types, their characteristics, all of the places that they could be, so that we can study the system in a really broad way without being limited by, so-and-so put a request in to be 10 miles from this substation 3 years from now, right? The idea is to formulate a really broad set of intelligence about what's good for the system. And then as we go out for requests for proposals, that's where the projects become very specific. That's where developers are bidding in. Here's what I can commit to. Here's the locations I can commit to. Here's the pricing I can commit to and the timeframes and all the rest of it. But you don't want to get into that in an IRP because it's much more limiting and much more near term in its thinking. So IRP is really designed to give us that 20-year look, not the next couple of year look and what's immediately on the horizon kind of thing.
I understand
Okay,
that.
Barbara, I'm sorry, I'm going to interrupt. We have
Okay.
at least 8 or 9 folks
We need to
waiting.
continue this discussion somewhere.
Okay.
Thank you.
Okay. Thank you, Barbara. All right, I'm going to move us on to Evan, and then Randy, you're up next.
Yeah, hi, this is Evan Rogers from MNerd. I'm just wondering how PNM is modeling for potential system enhancements from grid enhancing technologies like DLR, just to get more out of the existing system and kind of benefit ratepayers from cost savings.
Yeah, that's a really good question, Evan. So From the dynamic line ratings and ambient adjusted ratings, I think folks are probably aware we have a FERC order that we are complying with right now, us along with everyone else again who is FERC jurisdictional. So we are looking at moving our line ratings to dynamic line ratings and ambient adjusted ratings. What I will tell you when it comes to those as a part of the GETS, dynamic line ratings are effective in facilities that do not have another piece of limiting equipment. I'll give an example. So if we have a transmission line that is limited by its conductor rating, right? And that's typically the kinds of lines that you could effectively do a dynamic line rating on. If that line is conductor limited, but the next most limiting element is 5 megawatts away, an inline switch, a breaker, any of the other terminal equipment still will limit that line. So just because you can take a temperature, wind speed, and solar insolation variable on that conductor, number one, only about half of our facilities are conductor limited today. And almost all of those are limited by the next piece of equipment downstream, the terminal equipment, those kinds of things. So we are implementing those things, and those will be very helpful in operations. In terms of our ability to open up permanent transmission, firm transmission service, 8760 across a year, you cannot sell dynamic line ratings on a firm basis across a whole year. We might be able to sell it for 3 hours during a especially cold period or an especially windy day, those kinds of things. So I think about dynamic line ratings and ambient adjusted ratings in a operations context rather than a 20-year planning context, because it is not going to help me open up the transmission system and solve for my net peak kinds of problems, because that's when it's hitting those limits to begin with. So as we move forward, we're looking at ways to try to make sure as we go forward to try to remove limiting equipment as much as we can, make sure as we're designing our standards going forward that we're not limiting ourselves prematurely with downstream equipment, wave traps, inline switches, etc. Those kinds of things. That's part of our strategy for our engineering standards. When it comes to GETS, I actually have a white paper that I've widely distributed to stakeholders, and I'm happy to distribute that again. For the most part, PNM has been able to double the usage of its system since 1985 with only GETS. So we have utilized remedial action schemes. We have utilized all kinds of fax devices to ensure that we can pull more out of the system, remedial action schemes, etc. So I'm happy to provide that. But I think I will tell you, based on my 34 years of experience, the next best thing to do is more line in the air. I can't increase my capability on an 8760 basis to the California ISO today without constructing something. There is not a GETS, there's not a dynamic line rating that's going to get me there. And trust me, that is what we have used almost exclusively to expand the use of our system. So I think it's really important to note GETS, I think around the Albuquerque metro area, the last time a major transmission line was built was 1984. So everything we're doing is related to GETS, and we really do need to start thinking about what are those transmission facilities that can help us overcome some of the critical challenges. And this year, I'm really happy to report we are deploying advanced conductor on our system. So you'll see that going up kind of in the middle of the metro area. So very excited to be deploying the high temperature, low sag conductor carbon core this year.
Thank you, Lori. And I'm just watching time.
Yes.
Evan, do you have a
Sorry.
quick follow-up?
Oh no, I was just would be happy to see that white paper that you mentioned, Lori. Thank you.
Okay. We'll make sure we
sure.
get that out
Yep.
to GridWorks.
Sounds good. Thank you. All right, watching time here, recognizing that there are several hands still raised. So I'm going to ask those folks to sit tight for a minute. For those who have heard what they needed to hear and are ready to depart, Deb, maybe if I could ask you to pull up our slides. So just before we let the majority of folks go. Just so folks are aware, recording of the session will be posted on the GridWorks website. As I referenced at the top of the hour, we do have 2 other office hours that are in the works. These are both follow-up from workshop number 3. So the first is just kind of a cleanup from the remaining questions, and we don't want to go on to more material until we've digested fully what was from workshop 3. Secondly, specific to geothermal, there's been a lot of questions about cost assumptions. So both of those meetings are in the works, and we will be in touch shortly with dates and times for those. And then for the full group, our next workshop number 4, where we anticipate the base case modeling run results, March 11th, 9 a.m. to noon. Hopefully by now you know where to go for information, but look for it on the GridWorks website, and our team will be communicating details as we get closer to that. With that, I'm going to let folks go. Those of you that still have your hands up, if we could hold for just a minute and let's see what we can do here, whether we need you to drop things into the chat or if we can have a few minutes with the PNM team to address some of them. So Tom, I'm going to turn to you. Do you have a few minutes that you can stay, or should we have folks put their questions into the chat?
I have a few minutes I can stay.
Okay. Okay, so those who are remaining, if we could ask you to be concise, please, and the PNM team, recognizing that time constraints, to also be pretty efficient on your responses. We'll start with Randy and then go to Remy. Oh, Randy, I think try again on your audio. Okay, Randy, I know you were in the chat before. Maybe if we could ask you to drop those in the chat, and I can relay them. Let's go on to Remy, please.
Hey, Tom and Lori, thanks for this really helpful description. Wondering if you could say a little bit more about the which portfolios will be you'll conduct the nodal PCM for. Is it all of them, or are you going to select a few? And also just if you could say more about sort of that iterative process between the production cost and capacity expansion modeling. Is that a process that happens manually? And if so, like how many iterations are we doing? Sort of how do you know once the sort of portfolio has stabilized? So I'm wondering if you could say just more about those 2 pieces.
We won't be able to do it on all portfolios, so we'll concentrate on the main one. We haven't really defined exactly what those are, and we'd like to do some of the work first before because I think it'll help to clarify where we need to really do the nodal. There'll be some things that fall out of that you may decide from nodal you've got to do cost adders for certain resources in certain locations, no matter what. But once we get into that a little bit, we'll be better able to define it. We do know we cannot do it on everything. It's too much work. And to the extent that you get into iterations, we're hoping that we have enough bounds on this that the iterations are pretty limited, so that you go through something, you learn from that, and then other portfolios, you have a pretty good idea of how to really try to limit that to 1 or 2 iterations. And we'll be looking, the proposal right now is probably to look at the years 29, 5 years out from that, and then 10 years out from 29. So we'd be looking at annual values over those periods. We do have the ability to run longer, but the outputs are becoming impossible to manage. So it's better to work with a single year's output.
Great,
Thank you, Remy. Randy, I see in the chat here, he's asking about data centers. Does the model include large loads such as data centers? And how would the zonal model represent external connections?
On the latter one, the zonal model does have a couple of market areas where we have connections to external areas, and those areas typically are a capacity limited area that is dictated by a price curve. And historically, those curves have been Palo Verde, potentially adjusted to 4 corners for the market there. And then can you repeat the other question?
It was, sorry, I lost my chat. Does the model
large sta-
include
the di-
large loads?
The model will include what's in the loads forecast. So to the extent that there are large loads in the forecast, yes, it will include those.
Thank you. And then last one from Randy. What about candidate projects for 115 kV?
To the extent that really any project could be a candidate for 115 kV if it can be located near 115 kV and it's small enough. Projects in the 100 to 200 megawatt range are frequently 115 kV candidates as opposed to 345. It kind of depends upon how loaded the system is in an area. There are certainly areas where you'd have to go to smaller candidates than that because the transmission capacity is pretty limited on 115 in some areas.
Thank you. All right, I see 2 more hands and then we'll adjourn for the day, and then any cleanup we can pick back up in our office hour and workshop number 3. So Brian, you're up next, and then Darren will round out with you. Brian?
Hi, good afternoon. Thank you. I put my questions in the chat as well. The first one was on slide 7. The last bullet on there said that the model run determines flows on all lines and transformers using a power flow solution. I was wanting to know the time period of that power flow solution. Is it just the instantaneous flows, or is it kind of a static power flow solution, or is the need for a transmission line being based on just one fixed point in time?
No, the purpose of running the nodal model is to get away from that, not just have snapshots, but actually try to look at flows over 87, 60 hours each year. So that's what the nodal model will provide. It's really much more of an energy use of the system on an hourly basis.
Okay, so then what is the power flow solution used for?
The nodal model is to get there, it uses the power flow solution for the characteristics of each hour of the year.
It's a DC power flow.
Okay, thank you. Let's see, I had one more, I guess 2 more short questions. Slide 8, you showed a zonal, I guess you've already answered that. Can you confirm on slide 8 that those flows do include your wholesale transmission customer loads?
Slide 8 does not include the wholesale customer loads. That's the one with the zonal model topology.
Yes. Okay. So so those are flows on between the zones, I guess, net of those wholesale transmission customers, just flows available for your retail customers?
Those are showing the capacities between the zones that are estimated to be available for PNM use, because only PNM is modeled in that zonal model. That's why we want to go to nodal, because that really doesn't do a great job of capturing where the restrictions are for PNM when we try to add resources.
Okay. And then last one, just what is the depreciation life that you're assuming for your transmission projects?
It'll be 40 years.
Okay. All right, thank you.
Thank you, Brian. And Darren, thank you so much for your patience. We'll take you last, and then if there are folks remaining with questions, please drop them into the chat for us. Darren?
Thank you. With a name like Zigich, I'm used to going last, so that's good. Anyways, I think Brian answered my question. Well, you guys answered my question. So all the transmission is basically a 40-year life. So it's not tied to the asset. So if you're tying the transmission to a 15-year battery or a 80-year pump hydro facility, it's the same service life for the transmission.
Yeah, so
Yeah.
I'll answer that. This is Lori. We have depreciation schedules for all of our assets for our accounting and to follow FERC and all the other things. So you are never aligning depreciation schedules because transmission line life very obviously has a much longer lifespan than other kinds of assets like a 4-hour lithium ion battery, for example. So yeah, each investment that a utility makes is tied to a specific depreciation schedule that reflects that.
And then that would also tie to the cost recovery for that.
Right,
in
for
depreciation.
how you arrive at your revenue requirements for that asset, all your collected assets, but yes.
Okay, so any benefit of a long life generation or storage project would be simply at the production level.
I maybe didn't understand the last question, Darren. Maybe somebody else did, but if you'll rephrase it, I can try to.
Yeah, just going back to that example of a 15-year battery versus a 60-year pump hydro facility. Any advantage there with the additional lifespan is only at the production level, at the generation or storage level, not at the transmission. That's really what I was getting at, and I think that's what you're saying.
So Darren, let me see if I can answer your question. So when we put resources into Encompass, we put them in with their expected operating lives. And if, for instance, if you're saying like pump hydro has a 60-year life, that's what we'll tie it to. And so there will be a revenue requirement that's tied to that 60-year life. It would be depreciated over 60 years. And that will be accounted for in our expansion planning modeling with all other types of technologies with their own operating lives or expected operating lives.
So I think succinctly, yes, is succinct.
That was Shane Gutierrez and George Nail responding to your question, Darren. Okay, with that, we are 11 minutes over the hour. Really appreciate all of you hanging in there with us to try to get as many questions addressed. Before we adjourn, I'll just turn to my colleague, Margie Tatro. Anything to add or anything from the chat that we need to contribute before we close?
We do have one quick question. Glenn asked if the price curves that Lori mentioned will be available through the venue site. Is that something that would be publicly or confidentially accessed?
Yeah, the prices we're using, I think they may only be out there on an annual basis, but we got on and off peak pricing and things that show the pricing during solar hours versus non-solar hours on an annual basis are on the venue site now.
Yeah.
Great. And we can go ahead and put those price curves on venue, so that's not really an issue. We can make that available.
Great. Thank you.
That's all
Margie? Okay.
That's all I had, Kathy.
All right. Thank you folks for hanging in with us. 12 minutes past the hour. We really appreciate it. We will be in touch on these other 2 workshops in the next couple of weeks. Thank you so much.
Sounds great. Thank you. Bye, everybody.
Thanks, everyone.
Bye.